Since its discovery 7 years ago, the interstellar visitor named Oumuamua has puzzled scientists worldwide. While some researchers believe it to be a comet and others an asteroid, its unusual acceleration after passing the Sun left experts baffled. This sudden boost in speed even led to speculation that Oumuamua could be an alien spacecraft, a theory proposed by Harvard professor Avi Loeb. However, recent research has pointed to a more natural explanation, potentially solving the mystery once and for all. On October 19, 2017, the world of space exploration reached a new milestone. On this day, astronomer Robert Warwick identified an object in our solar system with a clear interstellar origin. This discovery was met with excitement but quickly turned to confusion, as the object's properties were unlike anything seen before. Named Oumuamua, meaning leader or scout, this unique object was initially classified as a comet. However, follow-up observations failed to reveal a comet-like tail or coma, leading scientists to reconsider. Just a week after its discovery, Oumuamua was reclassified as an asteroid. However, this too was uncertain. As astronomers analyzed its movements, they noticed an unusual acceleration as it traveled away from the Sun. This defied all known asteroid behaviors, prompting a surge of questions among researchers. Why was it speeding up? Initially, scientists suggested that Oumuamua's acceleration could be due to outgassing, a process where volatile materials escape from an object when heated by the Sun. This theory was common for comets but came with one major issue: outgassing is usually accompanied by rotational changes, which were absent in Oumuamua's case. This deepened the mystery even further. To uncover more, astronomers pointed nearly every available telescope toward Oumuamua. They noted strong fluctuations in its brightness, suggesting an elongated, cigar-like shape. Surprisingly, no dust was detected around the object, ruling out water content and hinting it might be composed of metal. The exact dimensions remained unclear, with estimates ranging from 800 meters to just 100 meters in length, depending on various assumptions. As for its origin, scientists could only conclude that Oumuamua came from somewhere in the constellation Lyra. Shortly after labeling it an asteroid, researchers reconsidered and once again categorized it as a comet. But even this wasn't universally accepted. Some studies speculated that Oumuamua might be made of frozen hydrogen or nitrogen ice, possibly a fragment from a Pluto-like exoplanet. Meanwhile, Professor Avi Loeb approached Oumuamua's mystery with an unconventional perspective, proposing that it might not be natural at all but an artificial creation. According to Loeb, the acceleration and lack of dust could indicate an extremely thin, large-surfaced object like a solar sail, a spacecraft propelled by radiation. Loeb's view, though controversial, wasn't immediately dismissed. In fact, the Green Bank Observatory in West Virginia even scanned for artificial signals from Oumuamua, though no signs of alien technology were found. As hope for extraterrestrial origins dwindled, scientists continued searching for more plausible explanations. By March 2023, astronomers Jennifer Bergner and Daryl Seligman proposed a natural but novel solution: hydrogen propulsion. After studying experiments from the 1970s to 1990s, they found that under cosmic radiation, water ice can break down into hydrogen molecules. These molecules could remain trapped in an ice matrix, only to escape when heated. Bergner and Seligman suggested that as Oumuamua passed near the Sun, the outer crust warmed, causing the water ice to restructure. This released hydrogen gas from tiny pores, creating a subtle thrust that pushed the object slightly faster. Hydrogen's invisibility to our instruments would explain why scientists saw no visible signs of outgassing or dust around Oumuamua. This special form of outgassing, known as molecular hydrogen propulsion, could indeed account for Oumuamua's acceleration if it were compact enough. For larger comets, outgassing would not significantly alter their movement. However, given Oumuamua's estimated dimensions of about 100 meters long and 20 meters thick, hydrogen escape could generate enough thrust to explain the observed speed boost. Though this theory remains unproven, it presents a coherent explanation for Oumuamua's mysterious behavior without relying on alien technology. It may not satisfy those hoping for an extraterrestrial encounter, but it showcases the beauty of scientific inquiry in tackling the unknown. The discovery of Oumuamua on October 19, 2017, marked a breakthrough moment in astronomy as the first confirmed interstellar object to pass through our solar system. Initially, this peculiar visitor sparked excitement, but the intrigue quickly grew as scientists noted several strange characteristics that left them scratching their heads. Was it a comet, an asteroid, or something else entirely? Oumuamua didn't seem to fit any known category of space object. When scientists first spotted Oumuamua, it was already on its way out of our solar system, moving away from the Sun. Calculations showed it had made its closest approach to the Sun on September 9, 2017. Surprisingly, though, it accelerated after passing the Sun, moving faster than it should have under gravity alone. This mysterious speed boost set off debates across the scientific community about what might be causing it. One of the earliest theories was outgassing, a common phenomenon for comets, where volatile gases escape from an object's surface when heated. However, outgassing usually causes an object to rotate, and Oumuamua showed no such rotational changes. Moreover, it didn't have a tail or coma, typical for comets, deepening the mystery and casting doubt on this explanation. In search of more answers, scientists focused almost every telescope available on Oumuamua. They noticed strong brightness fluctuations, suggesting an unusual elongated shape, resembling a cigar or needle. At the same time, no dust or water was observed around the object, suggesting it might be metallic or composed of other non-volatile material. This only raised more questions, as no other object in our solar system seemed quite like it. When traditional explanations failed, some experts, including Harvard's Avi Loeb, began to consider more unconventional ideas. Loeb suggested that Oumuamua might be an artificial object, perhaps even an alien spacecraft. He theorized it could be a solar sail, designed to be propelled by starlight. This theory drew much public interest and even led to radio telescopes scanning for signals, though none were found, leaving the question open but unresolved. For years, no explanation fully accounted for Oumuamua's odd behavior, but in 2023, researchers Jennifer Bergner and Daryl Seligman proposed a new theory, hydrogen propulsion. Based on past experiments, they found that interstellar radiation could cause water ice to break down into molecular hydrogen, which could remain trapped in an object's surface. As Oumuamua approached the Sun, this trapped hydrogen could have been released, providing a subtle, invisible thrust that pushed the object forward. This hydrogen propulsion theory could explain Oumuamua's acceleration without requiring an alien origin. As it warmed near the Sun, tiny amounts of hydrogen gas escaped, creating just enough thrust to account for the unusual speed boost. Unlike traditional outgassing, this would be invisible to telescopes and wouldn't produce dust or cause significant rotation, fitting the observations. Though the theory remains unproven, it provides a plausible natural explanation for Oumuamua's behavior, satisfying many scientists eager for answers. It also highlights the challenges of interpreting data from such rare interstellar visitors, as no other object like Oumuamua has been observed before. This solution may not completely end the debates, but it offers a fascinating insight into the complexity of interstellar objects and the ongoing mysteries they bring. For now, Oumuamua remains a reminder of how much we have yet to learn about the universe beyond our solar system, and how every new discovery brings fresh questions along with answers. The hydrogen propulsion theory introduced by Bergner and Seligman has shifted the conversation around Oumuamua, proposing a natural process unique to interstellar objects exposed to cosmic radiation. Over time, radiation could break down water ice into molecular hydrogen, trapping it within the object's ice matrix. When Oumuamua passed near the Sun, its outer layers warmed, releasing hydrogen gas through tiny pores. This release created a gentle but sustained thrust that increased Oumuamua's speed. Importantly, this process would be almost impossible to detect from Earth, as molecular hydrogen is invisible to telescopic instruments and would not produce the dust clouds typical of comet outgassing. This explanation bridges the gap between Oumuamua's strange behavior and natural celestial processes, offering a compelling answer to the questions that have lingered since its discovery. By demonstrating that hydrogen could cause the subtle propulsion needed to explain its trajectory, the theory dismisses the need for exotic or artificial explanations, at least for now. Still, the fact that Oumuamua exhibits such unusual characteristics shows how diverse and complex interstellar objects might be, suggesting we've only scratched the surface of understanding them. While this theory has received significant support, the scientific community remains open to new ideas. Oumuamua's case has underscored the limits of our knowledge about interstellar visitors, igniting interest in discovering and studying more of these elusive objects. Each one could provide fresh insights into the universe's many mysteries. As we continue to expand our observational capabilities, the story of Oumuamua serves as a powerful reminder of the unknowns waiting to be uncovered in the depths of space. And that's a wrap on today's Cosmic Mystery. If you're eager for more space discoveries, hit subscribe and join the Space Lab community. See you next time as we explore the wonders of the universe.